Hello again everyone, and welcome to video 5-1. This video is going to be the first video about pictorial views, and there's going to be 3 videos in this module. In this case, we're going to talk about the axonometric family of pictorial views. So to start off with, we have the part that is in your text, the blueprint for the part. While it's not in real life, it's not a very complicated part. However, when you draw it out using orthographic projection, you can start to see that even this part, which isn't that complicated, can be kind of confusing to look at. So when that's the case, we come over here and we create pictorial views. Now, there's 3 families of pictorial views: axonometric, oblique, and perspective. We're not going to talk much about perspective because perspective drawings are really complicated to draw. They do give you the most realistic view of a part. The whole purpose of a perspective drawing is to show you the part the way the human eye sees it. What happens with perspective views is all these lines, they come together, all these receding lines come together to meet at a point. Any receding line, any line that shows depth, they all come together at the same point. This is called a vanishing point. So what happens in real life when the human eye sees something, light tends to bend, and you've probably seen the same effect when you look at, say, a skyscraper or a long building. The lines seem to come together, or when you drive down the road, the 2 edges of the road seem to come together. So perspective views are great for that, but they are overly complicated to draw, and with the advent of computer-generated models now, very few people still create perspectives. You see them some in architecture, but that's about it. In this text, we're going to be concentrating on axonometric views and oblique views. And in this video in particular, we're going to talk about axonometrics. Axonometrics are the most commonly found pictorial views found on technical drawings. Anymore, though, they're all being replaced by computer-generated models. However, if you work with older drawings, you will see these axonometric views. And also, if you go to companies that don't use a full version of AutoCAD, if they only use AutoCAD Lite or some other CAD package, they may not have 3-dimensional modeling capabilities, so you still see axonometric views being created there. Oblique views are just not as common because the view that they give you is just not as realistic as an axonometric view. So let's talk about each of the axonometrics. The first one you'll see is an isometric. These are by far the most commonly drawn of the axonometric family. On isometrics, all of the receding lines, all lines that show depth, are drawn at a 30-degree angle, whether it's this way or this way. And when you look at an isometric view, you have these axonometric axes. And each of the angles between the axonometric axes for an isometric view are equal. As a matter of fact, isometric means equal angle. And now when we come over here, we can look at the dimetric. Now, dimetrics can be used to give either a lower view or a higher view, depending on what angles are chosen to draw the dimetric view. Any angle that the person creating the blueprint wishes to use can be used to create the receding lines. It doesn't matter if it's a 5-degree angle or a 10-degree angle or a 45 or 60, so on and so forth. The key to a dimetric view is that the angles between the axonometric axes, you have two equal angles and you have one unequal angle. Now, it doesn't matter which angles are equal. If you wanted to, you could create this angle and this angle to be equal, or this angle and this angle. It really doesn't matter, just so long as two of the three angles are even. Now, the reason we create dimetric views and trimetric views, for that matter, is what you see right here. I have a part that I'm showing you as an isometric. However, if I rotate the part, I start to create a dimetric view, and you see there's holes here on the bottom that you could not see when it was an isometric. So giving you a lower view of this provides the print reader with more information about the part. And finally, we can see trimetric views. Trimetric views are similar to the other axonometric views. However, with trimetric, none of the angles between the axonometric axes are equal. And what this does, it gives you more control over how you wish to show the part to the print reader. It could be a high view. The emphasis could be on this side rather than the front. However you want to do it. Trimetrics just give you a lot of control over how you wish to show the part. Okay, that's it for the axonometric views. Thanks for watching.